Guys, welcome to the Case YouTube channel again. We are delighted to have you guys watch this video. Today we are going to be solving a few questions on matrices and transformation. Okay, let's look at the questions then. So we are going to start off with June 2012, so that's June 2012. Question 7b. So the question reads, show that the transformation T represented by the matrix M equals that matrix you see there maps the whole space onto the plane this. Find the imaginary transformation of Roman 1, the line x equals negative y equals z minus 1 over 2, and the plane x minus y minus z equals 0. Okay guys, let's dive right into the solution. So let's just assume, let's just say all points x, y, z are mapped onto the points x prime, y prime, and z prime. Therefore, this means this m times the point xy should give x prime, y prime, z prime. So generally, to get the image of any point, we multiply that point by the matrix of transformation. So multiplying these two matrices, we now get this. So this times this times this times this equal this, and we now have this. Okay, now since they say we should show that it maps onto the whole space this. So basically, since our images are instead x prime, y prime, z prime, so we are instead supposed to show that x prime minus 2y prime plus z prime equals 0. So x prime minus 2y prime plus z prime equals this minus 2 this plus this, and yeah, just prove that it's equal to 0, and yeah, it's equal to 0. So let's look at the Roman 1 and Roman 2 of the question. Okay, the Roman 1 conclude, hence all points in the whole space are transformed into the points this. Since this is our whole space, so all the points are x, y, z, and this is the plane containing all points x prime, y prime, z prime. Okay, Roman 1. So the line this, which is in Cartesian form, so let's just say it's equal to lambda. So converting this particular Cartesian equation into vector equation, then we have r equals k plus lambda into I minus j plus 2k. For those, I don't think anyone should be having problems converting that. In case you have problems, please write it down in the comment section, and I'll just make another video and explain this. So converting this to the vector equation, we now have this, and if we group the I, j, and k components together, then we get this, and writing it in matrix form, we now have this. Now again, as I said before, to get the image of any points under a transformation represented by a matrix, then we multiply that matrix by that point and we get the image. So let's say the point is r, therefore the image r prime is just the matrix times the point r. So the r in this case is our line, which is of matrix form this. So we multiply and then we get this matrix, and converting back to vector form of a line, then we get this. And since our equation was given in Cartesian form, then it's good we convert this vector form to Cartesian form. So we now get this in Cartesian form, where r prime is the image of r. Okay, so we are done with Roman 1. Let's look at Roman 2. So for Roman 2, we are supposed to find the image of the plane x minus y minus z equals 0. So finding the image of this plane, let's make one of these particular variables subject of the formula. Now you are going to understand better with the tutorials. So if I take z this way and make z the subject of the formula, then I'll have z is equals x minus y. So if we say for any variable x and any variable y, such that x is a and y is b, then z should be a minus b if it should fall on this plane. So all points on the plane now should be of the form a, b, and a minus b, because it should be the x and the y and the z coordinates arranged as such. So the x is a, the y is b, and the z is a minus b if it should be on this plane. Perfect. So that is why we had to make one of these the subject of the formula. Okay, now before I continue, I just want to say basically the idea of all this point plane is you just getting a particular variable matrix which will express what you're being given. For example, for the line, the first thing we had to do was to get the variable matrix for all points on that line. So it's the same thing we need to do for this plane. We get the variable matrix for all points on that plane. Now let's assume all points x prime, y prime, and z prime are the images of these particular points a, b, and a minus b. Therefore, the matrix m times a, b, and a minus b should give you x prime, y prime, and z prime. And multiplying these two matrices, we now get this equals x prime, this equals y prime, and this equals z prime. And simplifying, we now get these three equations. Now, the key thing we are supposed to do here is try to create a plane, an equation of a plane from these three equations, such that we don't have the variables a, b, and a and b. Sorry. So the first thing I want to do is add equation 1 and equation 3. So this a variable can disappear. So adding this, I just get 4b is equal to x prime plus z prime, and 4b again is 2 times 2b, so 2 times 2b is equal to x prime plus y prime, sorry, z prime, and again 2b is y prime, so I can just substitute that in here. So 2y prime should be equal to x prime plus z prime, meaning x prime minus 2y prime plus z prime equals 0, and this is our image of the plane x minus y minus z equals 0 under the transformation T. Okay guys, let's look at the next question. So the next question basically is ICHS Mock 2020 question 6a, and the question reads: given that a equals this and b equals this, find the matrix product ab, hence otherwise find the point of intersection of the planes. This is this. Solution: so a times b is equal to a times b, and we just do matrix multiplication here, and we get this. Now remember, this matrix is what called the identity matrix. So generally I can say a times b gives the identity matrix, and multiplying all through by a inverse, so I'm going to have I times b, which is b, equals I times a inverse, which is a inverse. So b generally is a inverse, and a is also b inverse. So that's what we need to keep in mind. Now the second part of the question that says find the point of intersections of these three planes. So I can write these three planes as three different equations with three unknowns, and converting this into a matrix equation, then I now have this. And this matrix here that we have is simply a, so I can say a times xyz equals -5, 3, and 1. Therefore xyz is equal to a inverse times -5, 3, and 1. But what is a inverse? A inverse is simply b. So in this equation there was no need to use the whole a inverse equals cofactor of a transpose divided by determinant of a, because we were already told that a dot b is equal to I. So we could just put b there. So xyz equal b times -5, 3, and 1. So we just multiply b times -5, 3, and 1, and we get our coordinates. Hence x is -12, y is 23, and z is -13. Okay guys, we have come to the end of the video. If you liked it, please put a thumbs up down there. If you have any problem, please write in the comment section, and I'll gladly come to your need. Thank you for watching the video. Have a nice day.